Hello everyone. So today we are on day 21 of our DSA challenge, right? And the question that we're gonna solve today is longest consecutive sequence. This is the question. To know this, basically what a sequence is, it's basically, see, uh, let's read the what is a subsequence, right? Yeah. So basically, a subsequence is defined as a sequence that can be derived from another string sequence by deleting some of or none of the elements without changing the order of the elements, right? So think of this, string. So geeks is written as a string, right? So you have to find the subsequences of it. G is separately a subsequence. E, K, S. All these particular individual characters can be a subsequence. Ge can be a Ge can be a subsequence. E with this E is can be a subsequence. G with this K can be a subsequence. G with this S can be a subsequence, right? As it is written in the definition that by deleting some or none of the elements, so you are missing these elements and directly jumping onto K. You are deleting all these three elements and jumping onto S. See, not deleting as in you're not changing the string, but when you are finding the subsequence, right, you can say that you are forgetting the middle elements and then you are directly jumping onto some other element, right? So that is a subsequence. So see here it length of 3 maybe. So GKS is also a subsequence. You're deleting these two elements. So GES can be also a subsequence. Not sure where is it written. Yeah, GES is also a subsequence, right? So I hope you get the gist. And there can be, if I'm not wrong, let me go to Scalidraw. Yeah, there can be 2 to the power n subsequences in an array or string, whatever you are, taking 2 to the power n. So if n is the length of it, so let's just say if we take 1, 2, 3, right? So what is 2 to the power 3? It is nothing but 8, correct? So it can be 1, 2, 3, 1, 2, 1, 3, right? Um, 1, 2, 3, 1, 3, 2, or so this is 6, right? So here you can also take 2, 3, right? Here, and I think 3, 2, 1 can also be a subsequence, right? And 3, 1, 2 maybe. So these are the subsequences, right? You're deleting some elements and then you are adding on to some. Correct. Great. Um, so what you need to do in this question is, given an unsorted array of integers, return the length of the longest consecutive elements in the sequence. Okay. So see, you again, like we always go, our flow always goes in the questions that we solve, that we are going to forget what is given in the question that you have to solve in this algorithm, in this time complexity, in this space complexity. Obviously, see, if here it is written O of n, you get an idea at the end of the day that this question can be solved in O of n. But in an interview, will you give this direct solution? No, right? You will obviously start with brute force and then you will probably optimize that approach and then you will finally achieve to the best approach, that is O of n, right? So let's just forget this last line and then let me just copy this. Great. Uh, yeah. So here, if you notice, right, this is of length 0, 1, 2, 3, 4, 5. So 6 length, n is equal to 6, correct? Yeah. What is the longest subsequence? Now, what is the longest subsequence that has consecutive neat numbers? So 1, 2, sorry, 3, 4, right? 2, 3, and 4. And 100. Okay, so 200 is also given here. So these are all the elements that are given, right? Is 2 greater than 1? Yes. And consecutive to it. Is 3 greater than 2 and consecutive to it? Yes. So what will be the length? A length will be 4. Will 200 and 100 be consecutive? You will say no. So length will be 0. So the longest length, right, is nothing but 4. Now let's take another example, right? 101, I think it should be given. Okay, it is not, right? 101, 100, maybe 2, 3, or I can say that, hey, yeah, great. Okay. If this is the example that is given to you, you can say that, hey, I have 1, 2, 3, and 4, right? I have 100 and I have 101, right? What is this length? This is length 4. This is length 2. Why? Because 101 is consecutive to 100 and it's the next number. 4 is this and this and this, right? So this is length 4 and this is length 2. You have to return the longest. So you will probably return this, right? Now, what does our brute force look like? Okay. So if I just copy this only, the example that we took in the initially, see, you can start, see, you can have a longest variable, maybe which is equal to 1. Sure. I am here. Okay. Now, if this is my number, if this is my number, right, what will I do? I will say that first I will find I plus 1. Okay. So I'll go for a search. Hey, are you 101? Are you 101? Are you 101? Are you 101? No. So you're not. So longest remains 1 only. So my I comes here. This is 4. Then what I'll do is I will search that, hey, are you maybe are you 5? 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 No. So longest again remains this 200 for same. But here, if I come, right? If I come here, okay. So what will I do? I will say that are you 2, 2, 2, 2, 2? Okay, found 2, right? Now I becomes plus plus. So basically my I becomes what? Now I have to search for 3. Are you 3, 3, 3, 3, 3? Yes, you found. So longest becomes 3. Then becomes 4. So 4, 4, 4. Yes, 4 here is found here. Longest becomes 4. And this is what we call as the longest substring, right? So simple, straightforward, right? So if I have to write the, you know, maybe the code for it, so I'll go till n minus 1. Uh, where should I take the longest now? Okay, we'll see. So I'll go, my j will also start from 0 and will again go till n minus 1 because I have to check every element, right? Right. So if okay, what we can do is mm, okay, what we can do is give me 1 second. Now see here, I can do one thing, okay? I can say that, hey, let X be my array of I plus 1. Okay. And instead of this, I'll say that, hey, if linear search of what? Of an array of maybe X, right? Of maybe X. And not even this. We can simply say that, hey, let array of I, let X is equals to this, and I can probably search for X plus 1. right? If this is true, then I have a longest here, which is equal to 1, and I can also have maybe a count here, right? A count here, which can be equal to 1. I will say that, hey, count, you don't have to do anything. Count plus plus, right? And x also plus plus, correct? Correct. So if I do this, what will my time complexity be? Okay, give me 1 second and let me search for it, right? Let me search. Do you notice something? But here, what we are doing is we are only checking it for maybe once. But if I say this, then what happens? Then this loop goes on, right? Then this loop goes on. So while linear search is true, my x will be added, my count will be added. So every time, let's just say, if I just paste it over here, right, and check. So I will say that, hey, my longest, you are nothing but 1. Okay. I will start from I is equals to 0, right? What is my 0th element? 100. Okay. Maybe x also becomes 100. Correct. Count becomes 1. Because see, 1, why are we taking it 1? Because at least there's one element. The length will be at least 1. Okay. Cool. Why linear search? Now you already know what linear search is, right? So I don't need to even write the code for it. So you already know how this works. In array, x plus 1, what is x? So x plus 1 will be nothing but 101. Is 101 present here? You will say no, right? You will say no. So you will come out of the loop simply and I becomes 1. Great. Now my x becomes 4. What does my x plus 1 become? It becomes 5. Do you see any 5? This loop will not run. Correct. Mm, then your I becomes 2. What does your X become? It becomes 200. Again, do you see a 200? You will say, no, I don't see a 200. Count remains 1, longest remains 1. Now it becomes 3, right? This becomes 1. Okay. This becomes 1. What does my X plus 1 become? It becomes 2. Do you see a 2? Yes, you see. So increase this. X becomes 2 now because also count plus this is also there. Again, you will go. What is my why am I searching for x plus 1? Yeah, okay. So now I'll say that, do you find a 3? Because x plus 1 is 3. See? So yes, 3 is there. What I'll do is I'll increase the count and I will increase the x as well. Great. Again, what is x plus 1? It will be 4. Do you see a 4? Yes, you will see a 4. Count becomes 4. X becomes 4. Do you see a 5 here? Because x plus 1 will be 5. You will say, no, I don't. You will come out to the loop. Now what you need to do here? You need to write that, hey, longest will be nothing but max of longest and count, right? Now what will my longest become now? Because since 4 is greater, so it will become 4. Then where were you? You were at 3. So 0, 1, 2, 3. Now you come here. Your I comes here. Then again you search and you will find that no, this is your count will be only till be 2. So no, here it will be 3. And again, still longest remains the maximum. Longest remains the maximum. So you will return 4. Great. What will be the time complexity of this? Very easy to find. Very easy to find. O of n for I loop, right? Into. You're doing a linear search. You're doing a linear search, right? You're doing a linear search. Will that be almost equal to n? So you can say that, hey, I am using extra n square, the quadratic term, and I am not using an extra space. So O of 1, that is constant. Again, the interview will tell you that, hey, I don't need that this time complexity. I would want you to decrease it further. Great. Okay. So I will paste it again here. Now I will say, now I will say something. Do one thing for me. Now, this is the better approach, right? This is the better. I'd ask you to just sort this out. 1, 2, 3, 400, 200. Okay. I will start my eye pointer from here. Now, you will notice something, okay? Since we have sorted it out, since we have sorted it out, since we have sorted it out, the point is that every consecutive number will be together. Every consecutive elements will be together. Since now you will see 1, 2, 3, 4 are together, 100 and 200 are, maybe they are not consecutive, but yeah, they are together because it is ascending in order, right? So this is I, my longest becomes 1. Okay, my longest also remains 1, but okay, just hear me out. Okay, and I will say that, hey, you can say that let my uh, last element will be nothing but maybe uh, number dot min safe integer, right? Now, why am I taking that? Why am I taking that? This is important. This is important. I need to update my last previous number, right? My last previous number or last smaller number, maybe. I can, write it as last smaller also. Last smaller element. Okay. I will say that, hey, are you greater than, are you the next person to my last smaller number? Are you plus one to it? Basically, if I say that, hey, my last smaller number is 0, maybe assuming, then the next element has to be 1 just to keep the consecutive thing. Okay. You will say, see, I am here. No, I am not. What I'll do is I will update you. I will update you. I will keep you as my current element, my 1, and my longest remains 1 only. Okay, cool. Then I will move here, right? I can use red ones. I move here. Are you just smaller? Basically, are you the next number to the smaller number? Yes, I am. Becomes 2. Become 2. Great. What is the longest? What is the longest here? You will say that, hey, my longest, maybe we can have a count here. Maybe we can count, you can have a count here. So count was 1, maybe count was 1. Okay. Basically, we'll update the longest. We just simply have to return this. We just simply have to return it because at this point of time, you will get nothing, right? You will get nothing. So count becomes 1. And here, not count becomes 2. So this becomes greater. Okay, cool. Then this becomes, I comes here. Are you just the next number? Yes, I am. Count become 3. And this also updates. Are you the next number? Yes, I am. 4. Are you the next number? I is here. No, I'm not the next number. No, I'm not the next number. I am greater than it. I'm greater than it. My longest becomes the maximum of count and 1, and count becomes 1 again. And this becomes 100. This will change every time. This will change every time. Perfect. Yes. Now I come here. Are you the next number? No, I'm not the next number. So count remains 1 only. This updates. Are you the next number? Oh, you are out of bounds. What is the longest element that longest subsequence you got? Okay. Now, the question, now one more, basically what you can say is one advantage of using this sorting, this algorithm is that you will basically, you will not include any duplicates. So even if, let's just say, even if it had 1, 2, 1, 3, 4, again 100, again 200, right? This it would have been, and the sorted would look like nothing but 1, 1, 2, 2, 3, 3, 4, 4, 100, 100, 200, 200, right? This is how the next number looks, correct? Basically, the sorted thing looks. Okay. You will say, yes, this is how it looks. Now the point is, if my longest, if this is my, if I, basically I took this number and updated it with 1, then I come here. Are you the greater number? No, I'm not. I will update it with 1 only. With 1 only, no problem in that. Or maybe I don't even have to do anything. I don't even have to do anything. I can have a check over there that, hey, if you are not greater than 1 and you are not basically, if you're greater, if you're just the next number, then probably I can update you. If you're not great, just the next number, I can update you as well. And then I can, work upon my algorithm. So I will probably continue from here. 2, 2, 3, 3, 3, and all this will be ignored in one way, you can say. Okay, what will be the time complexity? O of n log n for sure, for sorting, plus this algorithm, what we are doing, this takes O of n because it is traversing the whole array, correct? What does this become? This becomes O of, yeah, O of n log n plus n, right? And what is the space complexity? No, no, I am not taking any extra space. So O of 1 or constant. Great. Now your interview might say that, hey, you are changing the array. You are sorting it out and you are changing the sequence of all these numbers. I don't want you to do that. Though I know it won't make any hard change. Though I know that this won't tamper your what do you call your answer, but I still don't want you to change the answer. I still don't want you to change the array. Okay, you will say fine, no problem. I will move to the optimal approach. Optimal approach. Cool. What is the optimal approach now? O of n will be the optimal. Perfect. That means you can traverse the array. That's it. Basically, you have to think in such a manner that, hey, I cannot run two loops, basically two nested loops, right? Because that will be O of n square. I have to do it in a single loop, Miss Baby, right? Okay, fine. No problem. Let's take a set data set. For people who don't know a set data set, basically, okay, in JavaScript, there is a thing called set, right? In C++ and Java also there is. In JavaScript, the set is by default unordered. By default unordered. Now, what is an unordered list? Unordered set. Basically, a set is a data structure which holds the unique values, So if we were here, if this was our array, if this was our array, it will only hold 100 ones, 4 ones, 200 ones, 1, 2, 3, 1, 2, 3 ones, and all these elements will be ignored because they are already present in the set. They're already present in the set. Okay. Let's try to do something. Let me just copy this only because now that I have it. Okay, great. Cool. What does my set look like? I will iterate the whole array and I will add all the unique elements. 100 added, 4 added, 200 added, 1 added, 3, 2, again a 3 already present. So we will not add it. 4 already present, 100 already present, 200 already present. Great. This is how my set looks like. Great. No problem. Now I will iterate in this set. Now I will iterate in this set. Remember, you have to iterate in the set only. Okay. First element, 2. Okay. If you remember, see, this is something that you have to assume. This is something that you have to assume that, hey, won't it be better if I start my algorithm with 1, right? Not, sorry, algorithm. If I start my subsequence with 1, because if I start from 2, and you remember that 1, 2, 3, 4 was your longest substring, correct? Your longest substring. 2 is kind of in the middle of it. 2 is kind of in the middle of it. So the count will be 3. The longest element will be 3. I need to have something. If I'll search that, hey, if my array, if my pointer -1, let's just say this is my iterative point, right? If this is my iterative point, is 1 present? Basically something -1, some that element -1. So element -1. Are you present? 1 is present. Oh, yes, you are present. Okay, no problem. I will not touch you. I will not touch you. Then I go to 3. Oh, 3. First of all, tell me, are you the first of your subsequence, or is there any element that is behind you? Maybe a 2, because element -1 is nothing but 2 only. I will see that, hey, 2 is already present. So I basically know that, hey, you are not the first element in the subsequence. You have to be somewhere in the middle or probably at the end. I don't care, but you're not the first element. That is for sure. 2 can be for 3. 2 can be the first element. I don't know, but okay, you won 1, right? Element -1 is equal to 0. Hey, I will search. Hey, 0, are you there? Are you there? No, you're not there. You're not there. So what I'll do now, I will do basically, I will search for the +1 elements. So I will let element x is equals to element. I will search for x plus 1 every time, right? I will search for x plus 1 till the time I get the longest of it. And my count becomes 1. Great. What is x plus 1? X plus 1 is 2. Cool. 2 is present. Count becomes 2. X also becomes, x also increases. X also increases. Now my element has to be 3. Hey, 3, are you there? Yes, I am. Count becomes 3. Now element becomes 3. X plus 1 is 4. Hey, 4, are you there? Yes, you are. I am here. 4. Cool. Now what does my count become? Now element becomes 4. Hey, 4, are you there? No, sorry, 4 plus 1, 5. Hey, 5, are you there? No, I'm not there. So my longest will be updated with max of L and count. And what does this become? This becomes 4 for now. Great. I will come here now. 200. Hey, element -1. Are you present? That is 199. 199. No, I'm not present. That means you are the first of your subsequence. That is for sure. Perfect. I will search for 199. Hey, are you there? No, I'm not there. So count remains 1, and longest will be maximum longest and count. And 4 is the longest, so I don't need to update it. 4. Again, hey, element -1, are you present? Yes, 3 is present. So you're not the first element in your subsequence. I won't touch you. 100. Is 99 present? You will say, no, it is not present. That means you are first of a subsequence. Great. You are first of a subsequence. Great. I will then search if 91, 99 is there, and I will increase the count and element and longest. But no, longest still remains the 4. Okay. Um, Give me 1 second. I will call you later. Yeah. Okay. So this is my longest. Cool. What is the time complexity? O of n to add elements plus O of n to traverse the whole, basically assuming all the elements are unique. See, this is when you write a time complexity, right? You take the worst case. And when you take the worst case, then you have to assume that all the elements are unique. All the elements are unique. Had it been repetitive, your time complexity would be lesser, obviously, because you don't have to traverse to all the nums. But again, you have to assume that all the elements are unique. O of n into I'm kind of running a while loop here. I will be running a while loop here, which will check x plus 1, element plus 1, basically. Are you present? Are you present? Then I'll update the count, and then, finally I'll update the longest. What does this become? Remember, for 2, I did not use. For 3, I did not use. For 1, I did use. I went till 4 iterations. For 200, I used, but I went till 1 iteration. For 4, I did not use. For 100, I did not use. For 100, I did not use. So 1 again. You will notice that what you are doing is you are running a 2n of loop here. A 2n of loop. Basically, how many elements are there? You're traversing them twice. You're traversing them twice at the worst case. At the worst case, if all the elements are subsequence, if all the elements are a part of the subsequence, great. So O of 3n maybe, or not 2n. It is nothing but O of n only. No, it should be not multiplied, I guess. It should be not multiplied. It will be nothing but basically you just have to add. You just have to. There is a 2. So every time you're what you're doing is every time you are running you are checking. So I by mistake wrote 2 into n. It is nothing but 2 because you're checking every element at max twice. One while you are running the while loop, and one when you are running your for loop for checking all the elements for traversing the whole set. So this is what it is. So O of 3n is the time complexity, and space complexity, obviously I am taking an extra space, so O of n, considering again if all the elements are unique. This can be written as O of n only because, I mean, you ignore the constants, right? Let's try to code it up. Let my n is equals to nums of length, right? And what I'll say is let set is equals to new set. This is how you initialize a set. Great. Now first I'll add all the elements in the set, basically all the unique elements. Set dot add nums of I. Let's try to see how does a set look like so that you get an idea if it's ordered or unordered, right? So for this 100 should be first if it is unordered, right? Okay, it's not st, it is set. 100, 4, 200, 1, 2, 3. Okay, if I take again 1, 2, 3, 400, 200, I'm taking them twice. How does my set look like now? Again, it will hold 6 elements only, 100, 400. It doesn't take any. So now you're sure that, hey, it does not take any extra. So it only holds the unique values. Great. Adding all the elements in the set. Traversing the set for. This is how you iterate in a set. So in set, basically this is an iterator. This is an iterator which points to this element, this element, this element, this element. Okay, great. If set dot has it minus 1. See, if it has it of basically minus 1, what did you need to do? You need to ignore it. You need to continue it. But if it doesn't have it, then you assume what? So, okay, let longest is equal to 1, right? If it doesn't have, can I say nums of length can be equal to 0? Okay, no problem. If nums of length, or maybe n is equal to 0, return nothing but 0, right? This is for sure, obviously, since here it is written that it can be equal to 0. That is why I added. If set doesn't have it, what will I say? I will say that, hey, my x becomes this and my counter becomes 1 while my set dot has x plus 1. Basically, you have the greater element. Count plus plus x becomes x plus 1. This is for sure. And at the end of the day, after this if, I will say that, hey, longest, you just become maths of what? Um, Longest and count. Okay, here, right? Here, count. And at the end of the day, I will return my longest. And let's try to see if it is running fine. Okay, wrong answer. Great. Output is 1. Okay, okay. Why is it so? Count becomes 1. Count is it? Set dot has x6. While set dot has x plus 1. Okay. X becomes. Let's try to see it on, our code editor for it. Our editor for it, right? Python tutor. Let's try to see what is the problem that we are facing. This is our array. Okay. N is undefined. Okay. N 12. Great. Set is set and longest becomes 1. N is equals to 0. Return. No problem. I will add all the elements in my set. Cool. Yeah. Okay. Traversing, traversing in set in JS, maybe, Should it be off? Okay. I didn't know that. I thought it should be in only. Let's try to think. Let's try to see. Should it be off? Oh, great. Sorry. My bad, guys. It should not be IT of in set. It should be offset, basically, right? So pardon my syntax errors, but yeah, I hope you get the point. So we are getting the correct answer. Let's remove this. Let's try to submit it out. Submitted. Great. Great. So I hope you understand, like this condition, right? This condition is very important. I need to see that, hey, is my previous element even present in this? If it is present, then why do I need to consider you as my subsequence, right? Because I know if one element will be before you present in the set already, then I'm sure that if you make a subsequence, you will always make the not the largest one because you are somewhere in the middle of it. If one element is present before you already in the set, why will I consider you and not that element first, right? This is the approach, right? So yeah, let's mark it. Maybe add, you need to define a set which holds the unordered values if element before the current element is is already present in the set, don't run the while loop. But if it is not, consider this element as your start of the subsequence and increase your count and longest according. Great. Let's try to save it up and let's mark it as done, right? Let's mark it as done. I hope you understood the question. I know this question might require you to, think a little deeper. Had this not been given, maybe many of us as well, I mean even me, including me, would have only reached till the point that you just have to sort it out. You won't have, you know understood the set basically. But again, every question is a new learning, right? So yeah, thank you so much guys for joining in. I'll see you tomorrow with another video. The question will be longest sub array with case sum. Yeah, okay, bye bye, thank you.